Number 14. Number 14 wants you to write the equation of a line that has an undefined slope that it goes to the point 25. Thank you. 14 wants you to write the equation of a line that has an undefined slope that goes to the point 25. So right off the bat, what kind of lines have slopes that are undefined? Vertical. What's the equation of every vertical line?
Equals a number.
What equals a number? Is it x equals a number or is it y equals a number for vertical? No, it's x. What's x equal here? Or the next problem. That's it. Guys, how many times have you written out this idea? Remember, vertical lines. I'm not talking over you. Vertical lines, slopes are undefined. And it's always x equals a number.
Oh.
That's always true. Same deal with a horizontal line. Horizontal lines, slope is always equal to 0, and it's always y equals a number. So if they ever give you, sir?
Wouldn't it be y equals a number for vertical?
No. Because what I want you to do is think about this graphically. If you think about this graphically, the ordered pair they gave us was what? 3, 4?
2, 5.
2, 5. Okay. So at that point there, if I'm going to become a vertical line, what's not changing?
That's not vertical.
The slope is not changing, but what order? Think of each smiley face as another ordered pair. The x value is not changing, is it?
No.
Nope. So that's why that's why the x values never change in a vertical line. The x values never change. It's the y values change. The x value stays the same. That's why we say the line is x equals some number when it's right. And it does the exact same thing when you twist it sideways and it's y equals. That means the y value never changes for a horizontal line. All right? That's how that works. And it's one of those things, for some odd reason, that students have the worst time getting their heads wrapped around that. So when you think vertical, do me a favor, just draw a line. And then think about ordered pairs. What never changes when you have that vertical line? Your x value. That x value will always, always stay the same. That's why it's x equals. Okay? Does that help on that one?
Yeah.
Okay. What else do you want to look at?
Yeah.
8. You're afraid of a fraction. Three-step process. We got a parallel line through a specific point. Excuse me, guys. So if I want to write the equation line that is parallel to that, I have to first of all identify my original slope. Now, one of the things we're going to work on today a lot more is when you have an equation of a line that does not have y by itself yet. In this case, we've got y by itself. We don't have to worry about anything. So, what's the slope of this line? Ladies, please stop talking. I don't want to go through this again, or you'll be the first people I move this year. I'm sorry, what was that? 7/3. What is parallel to a 7/3? 7/3.
All right.
Use point slope with the given values. Point slope, remember, and you fill in the blanks. You've got your slope and you've got your points. Now, instead of writing minus and negative, what am I going to shortcut that to be? Plus. So it's y plus 3 is 7/3.
That's negative times a negative equals positive.
It's not negative times negative, it's minus and negative.
Well, yeah. That's what I think of, and that's okay. My bad.
It's okay, but I see where you're going with that. And now it's just a matter of distributing. Now, we talked about this first hour, When you're distributing, make sure you send it to both parts, but don't freak out when you have the fraction. Because depending upon which calculator you have, if you've got the multi-view calculator, there's a button that says fraction bar. All you have to do is type in 7, bless you, over 3 times 3 and hit enter, and it does it. If you don't have that calculator, if you have your old graphing calculator, if you have, you guys have the pink one, you know, if you have that one, it doesn't have the fraction bar. But you can do the exact same thing by doing this. Parentheses, 7 divided by 3, close it, times 3. And you get the same result. It's just a matter of knowing how to use the calculator. Yes, sir?
I did the same thing with my other calculator because I put you can do like, you press BC, and then you put 7, press BC, go down.
Okay.
And then you do the same thing.
Okay. To be honest with you, I've only used your old graphing calculator maybe twice. I know there was a big push for the 73s back in middle school, probably about 3 or 4 years ago when you probably got that one. For the price that one is versus an 84, the more standardized ones, it doesn't do half of what that one did, or like the ones that we have now at the high school. I'm not familiar with that BC button. I would have used the parentheses, but if that's the shortcut, you go for it. I'm not gonna say no.
When I was doing my work, I didn't have this yet, so I just did 7 divided by 3, and I get a decimal, I just multiply by 3.
And that's another way to do it. That's absolutely fine, okay? What he was doing there, guys, is breaking it into 2 parts. 7 divided by 3, hit enter, times 3, hit enter, and it gives you the same thing. It works. It's a matter of understanding how calculators take the input within a problem. Calculators will only do what you tell them to do. And each calculator has its own specific mannerisms as to how it works into the order in which you have to put things in, okay? So if you know the little tricks here and there to make it work, that's great.
It's like a child.
It's what?
It's like a child.
Yes.
No, because like, you know,
No,
like,
you just quit while you're ahead. So we wind up with, what did I say it was? 7? Yeah. 7/3 times 3 was 7. Did I write it as 3/7 in the calculator by mistake? Nope, I did. For some reason I thought it was all 3. So then we have y plus 3 left over. And then how do I lastly move that 3?
Not multiply, subtract out, multiply. I got it right though.
So that's how those work when you're writing about parallels, okay?
man,
What else do you want to look at? We got time to do another one.
Oh, 8. I didn't get those, like, I don't know, 6 and 8. I know they're easy, but my brain wasn't just thinking.
This one was just getting into slope intercept form, okay? We're actually going to be practicing a lot of this today, so we'll look at 8, and we're doing okay on time. We can go back to 24 real fast. Now, when you're talking about slope intercept form, you want it to get y equals mx plus b. You want to get y by itself. You want to isolate a variable. Basically, in layman's terms, we're doing what's called a literal equation. We're solving for one specific part, okay? If I have to move everything else to get y by itself, what's the first thing I have to do with the 11x minus 8y? Subtract what? 11x. I can subtract the 11x. Now, oh, it's fancy that I have that bar there. What I want you guys to get in the habit of when you move stuff over to the left-hand side that has the x value, put that first. So we now have negative 8y is negative 11x minus 48. And I will say one thing that I've noticed a lot. You guys, when you rewrite equations, if there's subtraction signs, you accidentally forget that they're subtraction signs. You'll drop it down and write plus by mistake. So just be careful with it, okay? And now to get the y all by its lonesome, what do you do to undo multiply?
Divide everything by negative 8.
Divide everything by negative 8. I'm not subtracting here. I'm dividing. What's a negative divided by a negative? A positive. So I get 11/8 x And what's negative? Yes. You're done. And now you're back to slope intercept. And that's all those work. Now, from there, what's your original slope?
11/8.
What would be the perpendicular slope to 11/8?
Negative 8/11.
I know, it's when you get the weird ones here. All right, last one. Sorry, that's. All right. So it was a parallel problem. I apologize when I pictured that one in there. Yes, sir. When I snapped it in there, you put the line in. So going parallel, again, what's your original slope? Original slope. What's parallel to a negative half? Negative half. And now we just jump right into the point slope form, substituting in. I get y plus 1 is negative 1/2 x plus 4. And why did I write it automatically as plus and plus? It's the negative. Might as well make it a little bit easier on myself. Distribute and add. And then subtract the 1. Negative 2 minus 1 is not negative 1.
It's negative 3.
It's negative 3. There's a lot of little.
I got +7.
Whoa!
Make sure your names are on those. Send that up. Let me see what you did. We can figure that out. We're going to have a couple more examples to work through today.
I love doing this. It's so perfect. You're just like satisfied.
Cancel time! Right here!
Those are all, I can't do it ones like in a notebook like that, but I feel like it's not.
Why you give me one?
No, they're not. This one's like, this is just one. I can never get it on. I have 5 such ones. I hate my own
Next week.
Oh yeah, I saw that last night.
Right, it's today.
I've seen him every dollar.
Okay, you know, it sounds.
Thank you, thank you, thank you. Thank you, ladies. Thank you. All right, so last little bit of, as we're going through these things, is I want to make sure that you guys start to see like your last big thing you're screwing up. The last major problem we've been coming across when we're working with these problems has been stemming from when you see stuff that looks like this.
I like your dinosaur name, Carlos.
Thank you. And I want to write the equation of the line that is perpendicular through that point with that equation. And what I'm noticing a ton is that you guys are messing up when you got to get y by itself. Okay? So when you're working on getting y by itself, that's kind of a big thing. I'm going to go out on a limb on that one. There are, don't get me wrong, there are many different ways, probably about 2 or 3 different ways to always be able to identify a slope depending upon how the equation's written out for you to start with. This equation is written, do you guys know what form that's called? It's called standard form. You ever see that before?
Yeah.
That's your ax by equals c. To be honest with you, we don't use it a ton in geometry. It does become really prevalent in Algebra 2. One of the main reasons we use it in Algebra 2, and you don't have to write all this down, but if I'm looking at a graph, and I'm just some line. As I cross the x and the y intercepts, the y axes. If I cross the y axis there, what's the x coordinate when you're on the y axis? 0. And then what's the y coordinate when you're on the x axis? 0. So what you're able to do when you're in what's called standard form is that you can do what's called a quick graph. And it's really, really helpful in Algebra 2 because we use it all the time. It's when you do what's called cover and solve. Basically what I'm saying is that if I cover up x, I'm saying x equals 0. If x equals 0, how do you solve for y? Divide by what? Negative 5. What's negative 10 divided by negative 5? 2. That means my y-intercept would be at 2. And if I do the exact same thing with the y, if I say y is equal to 0, I'm looking for my x-intercept. What's negative 10 divided by positive 2? Negative 5. So by finding those 2 points, there's my line. It is a very, very fast way to graph. It's called quick graphs, just via intercepts. Because you only need 2 points to draw a line. We utilize it a ton next year. Now, one of the things I want you guys to get in the habit of, though, besides doing this, we won't need it now. I want to get y by itself. There's a couple ways I can go about it. Yes, ma'am. What's one way? Subtract the 2x. So if I subtract the 2x, drop it down, you have that negative 5y.
Negative 2x minus 2.
And then what do I do?
Divide everything minus 5. Then y is 2 over 5x plus 2.
Then you're done. Okay, and you're done. What's the other one I can do?
Well, it's from the notes.
Yeah.
I think you did add 5.
Yep. The other way I could do this is sometimes if that's negative, I might move that one first. So the other way I could do that, let me just move this over here. If I add the 5y,
You subtracted.
oh, sorry, thank you. I have 2x equals 5y minus 10. And then what would I do with that minus 10? I've still added it back the other direction. And then lastly, I
Divide.
cut it out. You can breathe normal. You'll be okay. Don't I get the exact same result? The only advantage I would say to, oops, got my X, right? The only advantage I would say to doing it this way is that I'm less likely to mess up if I have all those negatives. Because pretty much right away, the negatives become positive. You're less likely to forget a negative symbol. That's really the only advantage to one way versus the other. Either way is fine. Okay? Does that make sense? Now, from that, we have now gotten y by itself, which means you can quickly get your original slope. What's the original slope then?
2x.
What's the original slope here? 2/5. Very good. Is this a perpendicular or parallel? Perpendicular. What's perpendicular to 2/5? -5/2.
-5.
And I forgot my ordered pair. 4, -5.
You have to add that.
And what?
Never mind. I got it.
Why I wrote the ordered pair down again?
Yeah.
The reason I just wrote it there because it was all the way up the top of my page. I just rewrote it so I could see it. That's all.
Wait, can you go back up real quick? It's okay.
Said real quick. I did. See ya.
Don't come back.
Rewrite out your point slope. Then just know where the points to go. Sir. Thank you. Yes, ma'am. Fill in the blanks and go. Don't freak out because you have to multiply a fraction. You have a calculator that will do that for you. Or remember, when you're multiplying fractions, you're multiplying straight across. Set up your distributive property. -5 halves x plus, well, what's -5 times -4?
+20.
What's 20 divided by 2?
10.
And then what do you do to move the clock? And you're done. Okay? There are times it takes a little bit longer than others, but for the most part, everything's pretty darn straightforward. Yes, sir.
Go well, we had, just real quick.
Do
Not,
leave.
not real quick, like you did, just like,
Don't leave again.
no.
Take the old time.
Like the beginning of the equation, because I'm writing down. So I was gonna do it that way instead of that way.
Snowball.
It's like this.
I'm not on the Chromebooks right now. You can close the lid off. Thank you, sir. Thank you. All right.
Alright, I got it.
What? Okay. Take a minute or two. Let's go through that one, please. First thing you're gonna do is what? There's actually one extra thing you can do with this problem, and more specifically. Yes, sir.
Subtract 3x.
Good. Subtract the 3x. Did anybody divide the whole thing by 3? You could have. Do you need to? No. What I'm getting at here, guys, is that in this case here, notice all 3 of these values are all divisible by 3, which means there's a GCF. If you took the GCF out first, the only advantage is that the numbers are easy, they're a little bit smaller to work with. It's not a big deal because you'll have a calculator. You should be able to plug through without a big deal. Yeah. So move the 3x over. Now, do me a favor. When you move the x over, please put it first. And the reason that I'm putting it first is because it's starting to look more like plain old boring slope intercept. Okay? That's why I want to put that first. Go for it. And now what do? Divide by 12. Good. Hey, this does not mean subtract 12, ladies and gentlemen. This does not mean subtract 12. You'd be surprised. So we have -3 over 12. What does that simplify to be?
One.
Positive or negative?
Negative.
Good.
These
Yeah.
are the
We have a negative 1/4.
And then a negative 1/2. This right?
Well, it's not snow.
I've never seen that before in my entire life.
Let's go outside.
It is.
Perfect. We
Okay.
have class outside today.
What's that?
We have class outside today.
Sure, let's go.
Let's go, yeah.
Alright, let's go.
Now, come on, guys. Now we're only technically about halfway through the problem. Because now you're at the point where you've identified your original slope, which is
1, negative 1/4.
negative 1/4.
But
So now we start over with our original slope. It's negative 1/4.
Now it's going to be 4.
Very good. Perpendicular slopes are opposite reciprocals, so it's going to be a positive 4. Do I need to write that over 1?
No.
And now I go to my point slope form. Nice. It's just rain. Y plus 7 is 4x plus 1. Distribute through. Don't forget, draw arrows if you tend to mess up this little step. That only takes a second. And then how do you move that positive sign? Subtract it. Guys, it's just rain. Seriously, you've all seen rain before.
They said that about Hurricane Katrina.
It's just rain. And then it turned out to be
And you wonder why you guys are all bombed. Because you're worried about everything else besides what we're working on. Okay. Let's focus on what we're working on and not other things. What can you control? Doing your work. What can't you control? Everything else. All right, let's do a different one with parallel. Same basic principle. Same basic principle here when we work with parallel. You have to be able to get y by itself and go from there. So when you have 3x minus y is 5, I want to be parallel equation through the point negative 1, negative 2. 3x minus y equals 5. What? I'm sorry, go ahead. Yes, sir.
So all you have to do is identify the slope, right?
Yeah, we start with finding out the original slope. So we want to get y by itself.
Oh.
Now, there is a way to identify the slope out of this form, but I don't want to mess you guys up too much with
I
it.
thought it was like just do 3x.
No. In this case here, well,
That's what it says on the
we did this problem already?
No, it's just on the notes. Like I looked back and it's like the same problem,
So we subtracted the 3x.
but no, we didn't. We just said the slope was -2. Not for that one, but he just.
Yeah, no, that's fine. That's fine. Because I don't think I did one on a standard. Okay. Oh, here's the original slope. Here's the That's y by itself. Y by itself here. Hey guys, remember, in this case here, y is not by itself. That's why we have to move things around first. Once we get the y by itself, then we can pull the coefficient of x, and that'll help us get to the rest. I guarantee a third of you will do this,
And that's not right.
and that's not right. Because you got to put the negative in front. Okay. Ladies and gentlemen, it is the most common mistake when you're rewriting equations like this, bless you. When you're rewriting equations like that, if the y value had a negative coefficient, you forget the negative symbol. Yes, ma'am. I did. The reason I put a -1 out in front is because a lot of times when people just see the negative, they tend to forget what that means. They don't put the 1 there because they're just saving ink. That's all. So it's same thing if it's just y equals, it's technically 1y. But here it's -y, so it means it's -1y.
So we have to put 1.
You don't have to, but you have to remember you got to get rid of that negative. So how do you get rid of the negative?
Divide everything by -1.
Divide everything out by. The reason I put that -1 there is so that I remember, hey, bozo, I got to divide by -1 to everything. And now you get y by itself because -1 divided by -1 is just 1. And then -3 divided by -1 is 3. And now we have our original slope. Okay. So you have to take a couple of steps from time to time to be able to come up with the original slope. That's where a lot of you guys were having problems with. That's why I wanted to go through a couple extra of these as we did today. So rewriting through here, original slope is 3. What's parallel to a 3? 3. And then point slope.
Y plus 2
Very good.
equals 3 x plus.
Excellent. Distribute and solve. Distribute out. We have a 3x and a 3. And the very last thing to do then is to move the 2. How do you move positive?
Who said that?
You're done. Okay, good. Good, good, good.
Wait,
What's
I
that?
thought they put a 4 instead of +4.
Oh, sorry. Yep, I'm sorry. My handwriting gets to be kind of messy sometimes. Is that better? Let's do one more, then I'm going to show you guys where to find the homework. Bless you.
Thank you.
Take a couple minutes, let's do this one. We'll do another parallel real fast.
I think we should just have everything. I don't know. It wasn't.
Okay. So let's see what we get, because I know we're running a little short on time here. First thing we're going to do is move the 5x. Subtract 5x. I have a -4y is -5x plus 1. And then divide everything by -4. So we get a y equals 5/4 x minus a 4th. And that's how I identify my original slope. In this case, my original slope becomes a 5/4. What's parallel to 5/4? And now it's a matter of putting everything back together.
Y minus 2 equals 5/4 times x minus plus 8.
Again, this is a fraction that isn't going to be so scary because what's 5 times 8?
40. And then
What's 40 divided by 4?
Yay, I was right. And we added 2.
Final answer, I get a 5/4 x plus 2. Not plus 2, excuse me, plus 12. So, a couple things I want to show you guys then on the website, what I've started doing. Basically, it's coming down to the point of zero excuses for really anything anymore, because I am now creating videos for you guys that'll be embedded at the same spot. Right now, if you go on the website there itself, yes, ma'am.
I don't have the website.
sites.google.com, something or another. Yeah, slash Murphy, D428 slash Murphy Math, I believe. So on the geometry part right here, where it says 3.4, 3.5 para perp sheet, this is the assignment for Wednesday, which is today. I have you guys doing numbers 2 through 12 even, but I have you changing numbers 10 and 11, or 10 and 12. In the instructions on the worksheet, it has 10 and 12 being parallel. I want you to do them as perpendicular. So we have 2 examples of perpendicular, 2 examples of parallel. We'll collect this first thing tomorrow, and then we'll take our quiz right away. Okay? Now, the other thing I want you guys to see